In this lecture, I will explain about mode of operations, which is an important issue in cryptography. As you know, the block cipher encryption algorithms like DES normally forms a basic building block which encrypts or decrypts a fixed size block of data. For instance, the size of each block could be 64 in this encryption algorithm. However, in order to use such algorithms in practice, we usually need to handle arbitrary amounts of data which may be available in advance. In which case, a block mode is appropriate and may only be available only a bit or byte at a time. Hence, we review mode of operations in which some modes may use randomized addition input values to make more secure output. I skipped the history of this part. The well-known mode of operations are listed in this slide. We will start with the first one, electronic codebook or ECB. Before starting, we need to review some taxonomies and some words. First of all, initialize vector or IV. IV is a block of bits to randomize the encryption and produce distinct ciphertexts. We have also a terminology is nonce, which comes from number used once, nonce, okay, which is a random of pseudo-random number to ensure that our past ciphertext cannot be reused in reply attacks. In some references, you may see the initialized vector as nonce, but in reality they are not the same. And you know about padding. Sometimes the final block may require a padding to fit our block size. It could be done using different methods. For example, just adding null bytes at the end of the last block, or for instance add the n bytes with value n, or other methods for padding can be used. Okay, now we discuss about block cipher encryption mode ECB. In this method, our plaintext or message is broken into independent blocks, and each block is encrypted separately. As you can see here, we have the blocks of plaintext with the same size and bits, P1, P2 till the last part. Each block is encrypted using a key and will produce a cipher text. P1 is encrypted with key K and produces C1. Similarly, P2 is encrypted with the same key and produces the second part of ciphertext C2, and so on. On the other side, the destination will try to do similar things. Means that for decryption we need as input our ciphertext, which will be decrypted with the same key and will produce the plain text. In fact, using this method has some disadvantages. Okay, ECB is really simple. This is the advantage of this mode of operation. But what about the disadvantages? First of all, it is repetitive, which means that the same message and plain text is encrypted into the same ciphertext using the same encryption key. And it could be dangerous if the same message is encrypted with the same key and sent twice. Their ciphertexts are the same. In fact, you can consider that the attacker has access to a big dictionary which can map each plain text into a relative ciphertext. Even though ECB can be used in typical applications, for instance, when you need to transfer a short piece of information. It could be really efficient and simple and rapid. For instance, you can encrypt an encryption key with ECB mode and send it through insecure channel. And also it could be used when there is no redundancy in your data. In fact, ECB is deterministic in the other word, which means that the same data blocks which yield to the same cipher blocks. Okay? Hence, it is not recommended to use ECB mode more than one block of data. Okay. In order to solve this problem, another mode of operation was introduced, cipher block chaining, CBC. In fact, in this mode, we try to make our encryption schemes to be randomized. Repeated same plain text block will result different ciphertext block. In this method, each previous cipher blocks is changed to be the input with the current plain text block. You can see the CBC mode in this slide. Here, in each phase, you need the output of the previous step in order to encrypt your plain text, your block. Here, in order to encrypt P2, you need your encryption key along with the output, the ciphertext of the previous step, and so on. For the first part, or for the first block, when we don't have the previous ciphertext, we will use an IV. This IV will be the input along with our plain text and will be encrypted with our encryption key. And for decryption, we use the same mechanism, which means that in order to decrypt, we used the previous result of the previous section in order to decrypt our ciphertext. For instance, C2 is the input aligned with our key, and also the output of the previous section. And similarly, for the first time, we use an IV. It is important to know that the IV must be highly protected, and also IV must be shared between destination and between the sender and receiver. Okay? Even though we may encrypt the IV to protect it, because if we don't protect the IV, the security will be broken.